Hello students, let us solve one more problem from CSIR-NET December 2024 question paper. So this is very good problem. They given you a non-relativistic particle of mass m and charge q, which is moving in a magnetic field, and we need to find the Poisson bracket and Eijk component of Poisson bracket. These are the velocity components, where epsilon ijk, they are the Levi-Civita symbols. So let us see what we need to calculate. So we need to calculate, say, epsilon ijk and Poisson bracket vi vj. This we need to calculate. And where, what is Eijk? So this epsilon Eijk, its value is 1 when ijk are cyclic. When they are written in the cyclic order, its value become 1. ijk, jki, kij, that is 1. And E epsilon ijk is -1 when ijk are non-cyclic. And similarly, if this value becomes 0 when any of two indices are same, any of two indices are same. If any of two indices of ijk are same, like E epsilon iik, epsilon jj, or if not kk, if any two indices become same, then its values become 0. Okay, so let us now calculate it. So I want to find now first Poisson bracket. So in order to find the Poisson bracket, say I want to find vi vj. Now what is vi vj? Because particle is moving in a charged magnetic field, so we cannot write its momenta simply like its canonical momenta. I cannot write simply my vi. I have to add one term because of Gauss field. This field is there, and this become qi, where a are the component of magnetic vector potential. If I want to find b can be calculated using del cross a. So this is the expression for canonical momenta, and here I can find the vi value. So vi will be simply pi minus qi 1 by m. Now just put the values here. So this become 1 by m pi minus qai, and then you have 1 by m j means pj minus qaj, and this is your simply this one. Okay, and now I want to solve this one. So this will become what? 1 upon m square. Okay, and this is a curly bracket. You have a pi minus qai pj minus q aj. And let me simplify it further. So now this can be written as a Poisson bracket of pi pj, okay, minus q Poisson bracket of pi aj. Okay, careful about this in this ijk. And now next is minus q okay, minus q ai pj Poisson bracket, and then you have a minus plus q square Poisson bracket of ai aj. Now let me solve it more. So now you know this pi pj is 0. This term becomes 0. Similarly, AIAJ is also 0. And one more thing, vector potential, vector component only depend on the position vectors. They does not depend on the momentum or velocity. So now let me solve it now. So now this becomes, I have 1 upon m square, and then this becomes 0. Okay, and this is the minus q p pi pi, and first term is pi, then second term is aj, and then you have again minus q, and then you have a ai tj. This become my this one, and I'm solving this one now. So minus q, let me keep q inside only, minus inside only, and now this one q, and let me find the value of these two curly brackets. So this is the value of these two curly brackets. Say pi aj. What is the value of this one? This value will be summation k Poisson bracket pi del qk del aj, this is aj, and del qk, and this will be pk. And similarly, this will be now del pi upon del pk and del aj upon del qk. Now p does not depend on the position. This term becomes 0, and this pi by pk. So I can write in the conical delta. So minus, and this is del ik, and now aj upon del qk. Now this expression has only value when I equal to k. So solving this gives me del aj k equal to I del qi. Okay. So this term simplifies and gives me simply aj upon del qi. Now let me solve this bracket also. So now I want to write, say, curly bracket of ai pj. I want to solve this one. So what will be this one? This will be again summation k del ai upon del qk del pj upon del pk minus del ai upon del pk and del pj upon del qk. Again, this term is 0. Okay, so you have only pj by pk. So this will become summation k del of jk, and then you have a del ai upon del q, and this has only non-zero solution when j equal to k. So I can write this is the del ai upon del qj. So now this becomes minus minus plus, and this is minus only. So minus q del ai upon del qj. This is a very symmetric expression. Okay, very symmetric expression. Now only we need to find bring this expression in terms of magnetic field. Okay, so let me now solve for magnetic field. Now this is my Poisson bracket between the component. This I have got. Now I just multiply this by civic Levita symbol. So this become bi vj. Actually, you want the value of this bracket only. So this become q. This is m square. Okay, m square, and now I want this eijk del aj upon del qi minus eijk del ai. This is j, this is I, and that is del qj. Now what to do next? So this is a, say, now I want to write the magnetic field, I know magnetic field I can write B equals to del cross A. Okay, and the component of this BI, if I wanted the BI, that simply I can write this component I here, JK del A upon del QJ. Okay, by using this expression, IJK has the 6 things. IJK, we can write 1, 2, 3, we can write 6 combination. So we can write any component BX, BY, BZ. Okay, from this way. So this component of this equation can be written in civic Civita symbol. In this way, you can if you want to find, say, BX. Okay, so BX means this is the BE XYZ, XYZ del A and del A Z upon del Y. So you write the 6 terms. Okay, 6 terms. Some will be 0, some will be minus, some will be 1. So you can get any component if you want using this expression. Now let us see what we have. So now I have, say, E I J K V I V J. Okay, so this is Q by M square. Now what I can write, E I J K. Okay, so here you have a J, here you have I, and here this one. Okay, so this should be third 2 and this should be 1. Okay, so how can I write? I can write using the property of this symbol. IJK is simply equal to KIJ. Okay, nothing will change because here second is I. So I can write this E K I J del AJ upon del QI. Now this symbol is BI. Okay, whatever first is there, that is the BI. Now second is down, third is up. Okay, and similarly, I can write here EIJK. So I is up, J is second, so J is correct place. I have to change the position of K and I. Okay, so this will be now, if I have a EIJK, this will be minus, if I want to write K first. Okay, if I want to write K first here, so this will be K J I. Okay, so because after I, K is coming, so this becomes negative. So this becomes negative. Negative is already a negative, negative, positive, and this becomes same K J I del AI upon del QJ. Okay, now just use this definition and write the expression. So now this definition says your E I J K is simply E I J K, and then you have a curly bracket V I V J is equal to Q by M square, and this is your K I J, K here, I here, J here. This is BI component here, I component, BI component. This is BK component, so this is the BK. Similarly here again, K is here, J is down, I is up. This is also component BK. So now this become 2BK upon 2Q PK upon M square. This is the correct solution for this question. Okay, so see the options. So option says 2Q BK upon M square. This is the correct answer for this question. Okay, hope you like the solution. Okay, thank you very much.